Hi guys, this will be my linear algebra practice revision videos. So the questions that I will be doing here are actually questions that I am using for my revision for my tests. So these questions are actually fetched from online and textbooks, and I will post the links to the questions below in the video as well. So without further ado, this video will touch upon eigenvalues and eigenvectors for this set of revision practice 1. So for question 1, what we will be doing is we want to solve for eigenvalues. So given the following matrix, A equal to 1, 4, 3, 2. So this is our matrix A. We want to find all distinct eigenvalue for A. Okay, and to find distinct eigenvalues for A, what we have to do is we can solve using the characteristic equation. Characteristic equation is A minus lambda I x is equal to can then get the characteristic equation here. So solving for this, what we have is to find the determinant of A is equal to 1, 4, so 1 minus lambda, 3, 2 minus lambda. And to solve for this, what we get is 1 minus lambda, 2 minus lambda, minus 3 times 4 equal to 0. And if we solve for this equation, what we will get is lambda square minus 3 lambda plus 2 minus 12 equal to 0. And we can solve lambda is minus 5 and lambda plus 2 equal to 0. So lambda is equal to 5. Lambda is equal to, sorry, this is not 3, this should be 2. Lambda minus 2. So these are the two eigenvalues that we will obtain for the matrix A. So matrix A will have two eigenvalues. Okay, moving on to the next question. For the same matrix A, find a basis for each eigenvalue. So just to write out matrices in as for reference 3, 2. And we have lambda equal 5 and minus 2. Okay, so find the basis for each eigenvalue. So we want to get the eigenspace. And how do we do that? Can just do this. 5, okay, to 0. So we solve for this equation to obtain to find our eigen space. And this is just 1 minus 5, 4, 3, 2 minus 5, and make your augmented matrix. And if we solve for this matrix, minus 4, 3 minus 3, okay, what we will get is 1 minus 3 over 4, 0, 0, 0, 0. So this is what we will get. And we have x1 equal to 3 over 4, x2 is equal to some scalar t. And we have x is equal to 3 over 4, 1, where t is in the domain of the real numbers. And this will then be the basis for the lambda equal to 5. So Okay, so that's for lambda 5. Then now what about lambda minus 2? And we will apply the same algorithm to solve the problem. So it's 2, so 3 minus 2. So get the augmented matrix and we solve. So we can see that the first row and the second row are multiples of each other. And when we get the RREF, this is the form. We have x1 equal minus x2, x2, we let it be some scalar again. And we obtain this. So the basis for lambda equal to minus 2, I will not write it out. Just be this. And that's the basis for the eigenspace. And that is it for question 2. Okay. Now we want to diagonalize matrix A. Okay. So we are armed with our eigenvalue, eigenvector, and matrix A. So I'll write everything out here. So when lambda is equal to 5, then its basis is 3/4 and 1. So this is the eigenvector that corresponds to lambda equal 5. That's minus 2, I get it. Okay, so to diagonalize A, we use the idea of similar matrices such that A is equal to P, D, P inverse, where A and D are similar matrix. And to obtain this form, what we do is P will contain the eigenvectors, and D will be a diagonal matrix that contains the corresponding eigenvalues. Okay, and A is 2 times 2, right? It's a 2 times 2 matrix. And to diagonalize A, what happened is that we need two eigenvectors here, such that where they are linearly independent, and such that it forms the matrix P. And in this case here, we have the full set of eigenvectors, so we can form P. And P is just simply 3/4, 1, 1 and 1. And take note that the order I've chosen here, is arbitrary. You can swap these values, and the corresponding D here is 5 and minus 2. So if you were to swap the values, then you would have to swap the values of D. So minus 2 will be in the first column instead. And D must correspond to the columns of P. So just take note, P inverse. So to calculate P inverse here, okay, there are 2 ways. First way, we do this. We have P. All right. We form the identity matrix here, and then we solve such that you obtain this form here. So you will have four question mark entries here that you have to solve for. This is the first way to solve for P inverse. And the second way, which is my preferred way, would just be to use the determinant of A, and you will be able to obtain P inverse. So I will just you'll do the second way to illustrate. So the determinant 1 over determinant be 3/4 minus 1 times 1, and this will be 1, 3/4. And if I were to solve for this, what I will get is 4/7, 4/7, 4/7. So this is your P inverse. and we have form A is equal to P inverse. So just plug the matrices that we have solved for here, and that will be your final answer. Now moving on to the last question for this revision practice. Compute a to the power of 4. In fact, you can calculate a to the power of high powers of a the moment you are able to diagonalize a with ease. And I just take this time to run through why. So a is equal to p, and we have shown that in the previous question. So a squared is p inverse multiplied by p inverse. And from here, we know that A inverse is the identity matrix. So we have PD squared P inverse. And we will see that this can hold true here too. And if you solve by forward induction, you will then get AK equals PK inverse. Okay, so any powers of A is really simple to calculate. So now we want A power 4. So that's simply this. And what you have is P is 3 over 4 minus 1. Okay, D to the power of 4, because D is a diagonal matrix, you just need to multiply its diagonal 4 times. So it says 5 squared minus, 5 power 4 and minus 2 power 4. And this is your P inverse. Okay. And you just need to solve for these 3 equations. And if you were to compute it without any error, you would obtain this matrix here, 2, 6, 1 and 3, 6, 4. Okay, this should be your final matrix. So I am done with this revision video. I hope that this has been helpful. If you would like me to touch on certain parts of the question that I did not explain well, please do let me know. If not, thank you very much for watching.